Thank you, Tom. This is a paper that's in draft form, so if you're interested in a copy, you can email me. I should put my email address up there, but it's jmc16@cornell.edu. I guess I want to try to see if I can make the case and convince you that if you're dealing with and viewing environmental resources as an asset, and if those environmental resources can provide ecosystem services, that then there is probably a dynamic optimization problem that needs to be solved in order to properly value natural capital and ecosystem services. What do I mean? Well, natural capital, at least for an economist, would be viewed as a stock variable, something that would be changing over time, or a state variable, and its dynamics might be described by a difference equation in discrete time or a differential equation in continuous time. In contrast, environmental services are benefit flows that come from those stocks of natural capital. Some of the literature on ecosystem services say there might be 4 possible types of ecosystem services: provisioning, regulating, supporting, and life enhancing. Again, the perspective for economists are from the human Homo sapien perspective, or Homo economicus perspective. And the question often asked of economists, certainly asked of my colleague Greg Poe, is how do you value these, and what are they worth? Economists have sort of come down to sort of 2 major areas, and Greg might have some differences of opinion, to value ecosystem services. One is called contingent valuation, where individuals are actually asked to state what they'd be willing to pay to preserve an ecosystem service at a certain level, or how much they would have to be compensated if all of a sudden you were to deny them that ecosystem service. These 2 approaches for estimating dollar value of ecosystem services are a little bit problematic because oftentimes they're conducted when the underlying natural capital, the stock, is non-optimal, and therefore the flow of services are not optimal. And we probably prefer to try to estimate ecosystem service value and then the value of natural capital when those resources are more optimally managed. If stocks and natural capital are assets, and the value of ecosystem services should be estimated when those stocks are optimally managed. Management of natural capital will require solving a dynamic optimization problem. Optimal management, because the world currently isn't optimal, might have to be then viewed as a counterfactual. Let's give you an example. Let's consider the stock of oysters in Chesapeake Bay. Oysters have been described as providing at least 4 ecosystem services, according to the previous set of 4 types of services. They provide a source of food for humans, but also for other species in Chesapeake Bay. They remove nutrients from Chesapeake Bay, so they're filter feeders, and they're providing a water quality improvement service. They provide habitat for other species. The oyster beds that build up are like oyster shell reefs that provide habitat. And also there's a long history with cultural and historical aspects for the watermen in Chesapeake Bay who harvest the oysters. We'll consider just 2 ecosystem services, and this of course is going to lead to people asking, well, why not more? Well, it will lead into a higher dimensional dynamic optimization problem, which is where the computer scientists and operations research people come in. Let's let xt denote the biomass of oysters in Chesapeake Bay. ht is the rate of harvest. F of x will be a net growth function. We're going to describe then the change in the biomass of oysters by a differential equation, x dot equaling f of x minus h. And then we have to have a water quality index. And we'll just sort of arbitrarily scale this index so that it's less than or equal to 100, greater than or equal to 0, 100 being pristine water quality, maybe back in the days of the colonists settling mid-Atlantic area, and W equals 0, highly polluted, minimum water quality. NT is going to be the flow of nutrients into Chesapeake Bay. I'm going to actually make a heroic assumption that that is sort of fixed because the EPA is trying to regulate that via a total maximum daily load. And if I can do that, then I get a simpler differential equation to describe the change in water quality, which now depends on current water quality and the stock of oysters X. Presumably, greater stock of oysters means higher water quality. We're then going to have to value water quality, perhaps contingent valuation, and get a valuation function which would tell us what are the benefits, maybe to recreationalists, people who are out on the water boating, from higher water quality. Here's what the optimization problem looks like. Those of you who have maybe had some familiarity with Colin Clark's books on mathematical bioeconomics will maybe sort of recognize this as a setup for a bioeconomic model. In our case, it's a bit more complex than the original models in Colin's book because we have two state variables, the stock of oysters and the stock of water quality. It's a deterministic, continuous time problem. We can use the maximum principle, and if we do, we're going to actually get a single equation that could be at least numerically solved if I had functional forms for f, g, and pi. Pi is the net benefit from harvest, depends on also the stock size. V is that value of water quality currently at level W. This is sometimes called a fundamental equation of renewable resources. What the rest of the paper does is we specify functional forms, and then I go to the literature and try to calibrate parameters to those functional forms. And then we can actually get numerical values for this optimal size of natural capital oyster stock. And I can compare it to open access, which is the economist's version of tragedy of the commons. And if we do that, sensitivity analysis of the base case parameter set reveals that the cost of open access ranges from $37 to $79 million a year for Chesapeake Bay. The cost of open access included foregone net revenue from harvest because the optimal stock is higher, can support actually higher yield. And that foregone net revenue from commercial harvest was $6 to $30 million per year. The foregone water quality services range from 24 to 66 million per year. And with that, I'm done, Tom. I don't know if I did it time-wise.
Beautifully. You still have a minute. So that means we have a minute for questions.
Let me just again give you my email in case if you're interested in the draft of this article. It might be a paper in a forthcoming volume called Mathematics of the Planet Earth. And my email address is jmc16@cornell.edu.
Thank you very much.
Great. My colleague Greg Poe, who does contingent valuation.
No, but I'm not going to ask that question, but I wonder, I've discussed this with people with respect to eels, that you don't get the nutrient sequestration benefit unless you actually pull the eels out of the water. So if they die in the water, so that the carbon benefits will also be a function, or the nutrient benefits will also be a function of harvest.
So this is looking for a stock level that is optimal from both the point of view of the net benefits from harvest, but also from sustaining a stock that's filtering.
Right,
So,
but the
but it
filter
would be a
effect-
steady state stock. So harvest is set in steady state so that it leaves the stock the same, right? We're only harvesting net growth.
Right, but the amount of harvest, the amount of benefits from nutrient removal only occur if you pull the oysters out of the water. If you leave some of them to die in the water, they will regenerate nutrients. So that, I mean, I've heard of it.
Oh,
with eels.
okay. So you're saying harvesting is good because that removes oysters that would otherwise die and decay in the water?
And leave the nutrients, so the nutrients are recycled. And so that it happens for eels. I don't know if it's for oysters, but for
Yeah.
eels,
I don't have that aspect.
No, I mean, I'm just saying it might take them.
I need to look into it, I
Maybe
guess.
maybe it goes into their shells and so it's sequestered for a longer period.